So we're going to talk about oxidation reduction reaction, commonly called redox. I should have capitalized that O. Redox reaction. And we're talking about in this uh, gain and loss of electrons. And so compounds and elements are going to gain or lose electrons, and we're going to keep track of these, and we're going to count them with oxidation numbers. Something is said to be oxidized if it loses electrons and reduced if it gains electrons. And so we have this mnemonic: loses electrons, oxidation. Leo goes GER, gains electrons, reduction. There are other ones out there too. Okay, so that's the first couple definitions you need to know. The first thing to do is determine the oxidation state, and you're going to need your a copy of your periodic table. There's rules you can memorize, and I listed them in there. But here's the easiest thing. The one, we follow the octet rule, the noble gas rule, which means everything wants 8 electrons. And it can either get to 8 by losing a bunch of electrons, like chlorine can lose 7 electrons, that gets it to neon electron configuration, or it can gain electrons. Selenium could gain 2 electrons to get to krypton. And so we're going back to electron configuration and the idea that everything wants to be in this column. Okay, that's the first rule. So here are the rules. So we follow the noble gas rule, which means everything wants 8 electrons. The more electronegative element will be negative. That's always the way it will be. The less electronegative element will be, it will take a positive charge, and the total oxidation state must add up to the total charge. So make sure you pause the video and write these rules down and have them in front of you as we work these, as I'm going to have to keep erasing them to have room to work. Okay, so I'm going to do a couple with them there. Let's look at sodium chloride. And what are the oxidation states of the elements in here? Well, we note over here that chlorine is over here, and in fact it wants to become -1 because it needs to gain 1 electron to become like argon on the periodic table. And sodium is down here, number 11 element, and it wants to go all the way to neon, and that's losing 1 electron. So the oxidation state of sodium is +1, and chloride is -1. Gained 1 electron for the chlorine, lost 1 electron for the sodium. Let's look at these columns. We're going to note that this column tends to be -1, this column -2, this column -3, and this column +1, just like we memorized a long time ago, +2, +3. They don't have to be in this, but those are the tendencies. So if we look at something like SO2, we notice oxygen is more electronegative than sulfur because oxygen's higher. Electronegativity goes up and over. It increases up and over. So the oxygen is clearly going to gain 2 electrons to get like neon. The -1 controls everything. So each oxygen is -2. And we know what's the charge on this. The charge is 0. There's no charge on SO2. And so that leaves only one thing that sulfur can be, +4, because this has to add up to 0. Let's try this molecule. Okay, SF6, and we will note that fluorine is clearly way more electronegative than sulfur, and so fluorine will be -1. It can only gain 1 electron, and I have 6 of them, -1, -1, -1, -1, -1. That's a 1, 2, 3, 4, 5, -1. And the charge on this molecule is 0, so the sulfur must be a +6. So sulfur equal +6, and each fluoride is equal to -1. It's not -6 for the fluoride. We want only only the oxidation state of one fluorine atom. All right, another one here. So let's do chromium CrO4 minus 2. And so when I look at this, I note that chromium in the middle of the periodic table right there and oxygen up on the far right, upper right. I note that oxygen is more electronegative, so it'll gain 2 electrons and become minus 2. That is the oxidation state of oxygen. Each oxygen, I have 4 of them, so minus 2, minus 2, minus 2, minus 2. And that makes the chromium, this has to add up to minus 2 because of the minus 2 charge. It's not 0 this time. And so in this case, the chromium will be, the only thing it can be is plus 6. So that's the only thing that will add up to minus 2. Do a couple more of these. Okay, here's a hard one, NaH. So we'll look over here. Na and H are on the left side. H wants to be plus 1 and sodium wants to be plus 1, but they can't. And so the more electronegative will be negative. So the hydrogen must be minus 1, which that works because it gets us to the noble gas configuration of helium. And therefore, sodium must be plus 1. So, there's examples of it. How about CO2? Oxygen's minus 2, carbon, and there's 2 of them, so carbon must be plus 4. So we'd write carbon equal plus 4, oxygen equal minus 2. There's one little other tough one that I want to do, and that's a peroxide. And so we'll look at something like this, F2O2, fluorine peroxide, okay? And so this is a tough one. We'll look at which one's more electronegative, and the oxygen and fluorine are up here, so the fluorine is going to be electronegative, and so it's going to be minus 1, so it gains 1 electron. That means since there's 2 of them, each oxygen must be plus 1, adding up the 0. So there's an example of oxygen not being minus. So fluorine is minus 1 and oxygen is plus 1. Okay, there you have it.